excuse me, your C value for any one of the standard form equations is always the y-intercept. Because if it's the y-intercept, it means your values of x is 0. 0 squared plus times something plus 0 squared times something is always going to be 0. So that's why that we start at your y-intercept. Obviously, it would come back negative, but we don't really worry about that. So when you set this up and it gives you this really nice equation to work with, they're talking about time in seconds, and it equals some h value in height. So your x values in your calculator are seconds, your y values are heights. So, and I think it asks you in this one, what's the rocket's maximum height? Well, the easiest thing to do here is just do the opposite of b over 2a, and you get 3. That's your axis of symmetry. When time is at 3, you substitute in for 3, you get negative 5 times 9 plus 30 times 3 plus 10. Is that negative 45, 90, so it's 45 plus 10 is 55. Maximum height is at 55 meters. I think if you did that in the calculator and you did calculate the maximum, I think the coordinates were like 3.0001 and like 55.00 something or 49 and something. If you ever see that, remember that means it's 3. If it's 2.9999, it's 3. Okay. If it's 1 times 1.2 e to the negative 12, it's 0. Things like that. That's what that was. We okay on these? Standard form are nice. Friendly. You want to hug it because you love it. See? It loved me. It wanted to come and give me a smooch. What? What? I'm an idiot. It's okay. I get over it. Water balloons. Who doesn't like water balloons? And whose bright idea was it to make water balloons that have colored ink in them? I see these all the time at Walmart. My kids see it. Ooh, water balloons. They're on clearance. Daddy, let's buy them. And they're the ones that have color on the inside. So when they land on you, you get dye marks on you. I don't want that on my clothing. I don't want that on my yard. I don't want that anywhere near my cars. So, and then of course, when you have small children and they know how to make water balloons, because you buy the nozzles that you put on the garden hoses. Water balloon. It's anyway. So you got a water balloon problem. The water balloon is catapulted into the air so that its height h in meters. After t seconds, it is blah. What is the height after a second? What is the easiest way to solve these problems? Substitute in, plug and chug, or better yet, the calculator is one giant plug and chug machine. Did you know that? It is. If you go to the y equals and you want to plug and chug these values, what is it after 1 second? All you do is put the function in the calculator. Negative 4.9x squared 27x plus 2.4. And if I go right to my table, there's my plug and chug. After 1 second, it is 24.5 meters in the air. That's what that means. What this allows you to do is not make a math mistake, especially if you ever have a negative number. You won't screw up squaring something. Table functions on the graphing calculators are your best friends because it eliminates a lot of PEMDAS errors. It really does. Okay, it really does. For how long is a balloon more than 30 meters high? Well, it jumps over 30 meters at 2 seconds. There's 2, so it'll be 1, 2, 3. So after 3 seconds, for 3 seconds, it's above 30 meters. That's what I would say. If I wanted to be really, really, really fancy with that and wanted an exact number, what would I do? What's that? what this graph looks like. What goes up must come down. It had a maximum height. Let's see, change our window here. I think it's make our Y maximum, I don't know, 30. Let's see what this does. Oop. Bring it out a little closer. So we're flinging these things way up in the air. But they're not going very far out. Okay. So what I did there is I adjusted my window. Hi. Hey, did you guys know each other?
Yeah, oddly enough.
I'm
This one's
sorry.
a barbed wire. Can we borrow him for a second?
You got $1?
No.
I suppose. That's fine. So when we look at this graph, oops. One of the things we could do if we wanted to get an actual amount of time, if I wanted to, this one just said for, I think it says for how long is the balloon in, above that. If you wanted to find it specifically, if I draw that line in at y equals 30, it would intercept the parabola at 2 spots. Remember the fire hose problem with the 25 feet? Where we hit second, calculate what is this value, what is this value? If I did that, I could find specific x coordinate from here and here, find the distance between the two. Remember, that's dealing with time, and that can give me my seconds without rounding error, just saying, oh, about 3 seconds. I could say it's actually 3.6 seconds. Does that make sense? If I ask you something specific like that, it'll be say, give me a specific answer. Fair? Otherwise, table-wise, we just count. It's pretty quick. What is the maximum height of the balloon? Well, we can do a couple of different things. You could have used your, we could have used our second calculate function just to find the maximum height. You could have used the quadratic formula, find the x value from that, and that'll give you your zeros, and then you have to find the axis of symmetry and go through there. Or you can find the axis of symmetry out of this, the opposite of 27 divided by negative 4.9 times 2, that's a big pain in the butt. These are ugly numbers. Not that all numbers, numbers are technically ugly, but these are ugly numbers. So what I would do, second, calculate, dun dun dun, maximum. And I'm hopefully by now you guys understand this whole idea between left and right boundaries. We're okay with that? We're not screwing that up anymore, I hope. Enter, go around the curve, around the bend. That's a Pearl Jam song in case you guys care. And there's your maximum height, 39.6 meters. You round it to 10. Usually around 2 decimals. Okay. When will the balloon burst as it hits the ground? Well, what are you looking for? The x-intercept, which is called your 0. You're trying to find your 0. Again, you just hit second, calculate, 0. Now, when you're on a bound, when you're looking to find an x-intercept and it's on the right, we're going to the right, your left boundary will be above, it'll be above the axis. Or if you just watch your y values closely as you're using the calculator, you owe me $1.
All right. Hey, you owe me $2 million.
Oh, yeah, that's right.
Can we owe you 2? Is there anyone that would volunteer for a short interview? Anybody want to be a pick?
Maddie Reinhardt.
Jolie, go! You're down.
Hey,
You're gonna be in the water.
It's the barbed wire.
They can't tell you. You just have to walk out there and find out. Izzy, go!
Maddie, go!
Will you actually give us $1?
I just tore my ACL.
I think Brayden should go.
Brayden, go!
I think Maddie should go. Be mad.
Were you like worried that your leg hurt? You could
We'll be
walk.
quick. Don't worry. It's nothing.
My liver.
Bye, Brayden.
My liver.
Miss him. Miss him already.
Do you get the reference? My liver.
Maddie, that was your time for story.
What are you talking about? No.
You would be famous.
I do not want to be famous.
It's
No one's
it's-
eye contact. No, it's not. I do not want to be famous.
yeah, she got the reference from Beavis and Butthead.
No, I'm not.
Liver. Beavis said that a lot. He got hit by Butthead, or Butthead said it. Wait, Beavis.
You guys talk.
Anyway, another thing you can figure out is when you're trying to find where it's going to cross, notice your y values. Y value is positive, y value negative. Y value positive, y value negative. Y value positive, y value negative. What do you think happened?
It hit the ground.
Yeah, it hit the ground. It went over. So here's your positive value. Here's your negative value. And hit enter. After 5.6 seconds, when I round that to the nearest hundredth, because it's 5.5977.
Wait, that's, when it hit the ground?
Yep.
I just put when it hits. What you were saying, when does the balloon hit the ground? When does the balloon hit the ground?
When will the balloon burst as it hits the ground?
That's, as it hits the ground.
Okay, knucklehead. Nancy's walking.
I hated this one.
Nancy's walking. Nancy's walking 15 meters diagonally across a rectangular field. She then returns to her starting position along the outside of the field. The total distance that she walked is 36 meters. What are the dimensions of the field? Well, first of all, it's a very small field.
A plus B plus 15 is 36.
Make it even more difficult. She's walking diagonally. She goes this way. She went that way for 15 meters. She has a total distance of 36 meters to walk. If she walked 15, how many are left?
Only one.
Well, she's got to walk back up here and then here to get back over. Well, if this much is x, how much is the other side? No.
2x?
Think about how much you have distance you have left. What is it? Very good. And this is a right angle because it's a rectangle. Pythagorean theorem. It's Pythagorean theorem.
Probably.
It is not a 45, 45, 90. It's not a
That's why it's
36, 90.
That's why it's a squared.
That's why it's a squared, b squared equals c squared. So x squared plus the quantity 21 minus x squared is 15 squared. A bunch of math, you get this. 2x squared minus 42x plus 216 is 0. What I did at this point is that I have pseudo clean numbers, but notice everything's even. I'm just going to divide everything by 2. Take the scalar out, just to make it easier on your brain. X squared. Wait, why are you laughing at that?
Because they shook hands.
Oh. Thank you for taking one for the
Brayden,
team.
what did they ask you?
What they ask you?
Some point.
See you guys.
They're like,
That's one way you pay me that much.
I could write you a check, just don't cash it for like 30 years. Or 60. Yeah, cash it about 65 years.
So cash it in when you're dead.
Yes. Now at this point, what I would say is, hey, what times what's 108 you add together to get negative 21? 2 negatives. Hey. Nine and 12.
9 and 12.
Okay, the reason why you don't know that, because you guys don't use tape measures. When you measure things by feet, 12 inches is a foot, 24 is 2 foot, 36, 48, 60, 72, 84, 96, 108. Remember our times table?
yeah, I beat you.
No, you didn't.
Yes, I did. I didn't know we had to say we're done.
Name a time and a place, and we will revisit that. Gives me 2 zeros. Gives me a 0 at 12 and 9.
I'm so stuck at like 36 squared to 21 minus x plus x squared, which is negative.
No. Pythagorean, you gotta FOIL it out.
Yeah.
Maddie, give me Maddie.
Well, if you use, if this is, if x is 9,
You watch a movie?
then this side would be 12. If x is
It's
12,
quiz.
this side would be 9.
Joel, you watch a movie.
Yes.
I did a little bit different.
I'm serious, if you don't believe me.
Guys, hold on.
Split up, where you split up negative 42x
Yeah.
into
Oh, you,
18 and 24.
that's fine. Yeah, well, as soon as I see this though, Trap, as soon as I see that all these guys are even, I'm gonna simplify it out right away. That's just quicker. In my mind, I think it's quicker, that's all. I mean, you could have just graphed this and found your zeros, because it looked clean. You could have factored, you could have put the quadratic formula, gotten 9 and 12. This one, you could have, well, you wouldn't want to complete the square root with the 21, but it would have all worked. All those methods would have worked. That one was just the quickest. That's the way that I thought. Okay. The flower bed. Flower bed. Humor me,
With
please.
like one flower in every row. So you have to study everything.
Flower bed. The interior portion of the flower bed is 8 by 4. The total area of the whole thing is 165. Now, what happens here is that you have uniform width with all these flowers, which I'm going to move. We're cultivating the flowers right now. Which means, when we get to this part here, we need to figure out, excuse me, what's the uniform width going on the flower bed? So to set this one up, we know that the total area is 165. Well, the total dimensions would be 8 plus 2x. And the other side going this way would be 4 plus 2x.
I should just get that.
Uniform width on both sides. If this far is 8,
Yeah.
what's 8 plus x plus x?
But how do you know? What does it have to do with the number 8?
They gave you this interior dimension to start with. It was 8 by 4. So if from here to here is 8, and this much is x, and this much is x, what's the whole thing? How many x's are there? So it'd be 2x plus 8. That's it. That's all it is. Okay. So after this,
Oh, okay.
you got it now. So now we know that if I multiply these two together, these two dimensions together, and 4 plus 2x, it has to equal the overall area of 165. Foiling this out, I'm going to get 32 plus 24x plus 4x squared. I'm going to bring the 165 back and set it equal to 0. And I'm trying to find the zeros. I need to find the actual zeros. I don't want to try to factor that because that looks like it's going to make me cry. So one of the ways I can do it is just do calculate zeros on my calculator, or I can use quadratic formula. Either way, it's fine. What's that? You can. If I want to calculate my zeros here, do this one, let's see, it's 4x squared, 24x minus 133. Oh, I forgot to put a plus sign in there. If I graph this, think about what the values of x are giving you here. You're going to get a positive value of x and a negative value of x. Which one do you want? You want positive, because we can't have a negative width. So you're just looking on the calculator then to find out where does it cross the x-axis so that it's positive. So I'm just going to hit a second, calculate, 0, and move it over. Oh, there it is. All right, so it's positive, negative. Okay, so it happens between 3 and 4. So I'll hit enter, 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 3.5. The width would be 3.5. Is that what you got? What'd you get? Just remember what these things are asking you. That's kind of what it works out to. And then last but not least, we have the mural problem with some funky picture on it. Oh, okay. So we have this funky pattern on the inside of the mural. Beggars can't be choosers. The wall itself is 15 by 12. The mural is going to be less than that. The mural is to be painted on a wall that is 15 by 12. A border of uniform width is to surround the mural. A border of uniform width is to surround the mural. If the mural is to cover 75% of the area of the wall, how wide must the border be to the nearest tenth of a meter? So, what is the total area of the wall? 15 by 12. It's 180. So it's 180, and I need to find 75% of that. So I just multiply it by 0.75, which means my overall area of the mural has to be 135. The area on the inside of that will be 135. Okay? So what we need to do is we need to figure out how do we write that up for the dimensions. Well, in this case, I need to find the dimensions on the inside. Very good. It'll be 12 minus 2x, 15 minus 2x, and I have to set that equal to 135. And we get, after a bunch of math, we get that. One of two things we can do. We can put that in our calculator, find the zeros. I can use quadratic formula, because I'm sure as heck not going to try to multiply what times what's 180 that I can get to 54. Why not? Because I already did it, I know it doesn't have factorable terms. No solution, yeah. Let me show you what, I used quadratic formula this time, because I think I did this when I didn't have a graphing calculator on me, so I just wrote it out.
Can you complete the square?
You could, but you're gonna have to divide everything by 4. You know, so you have 4, this would be 1, 4 doesn't go into this evenly, so I wouldn't bother with that. If I use quadratic formula, I get 54 plus or minus the square root, 54 squared minus 4, and a 45, all over 8. And I did that one because I didn't have my graphing calculator on me when I did this, so I thought it was a little easier just to write it out. You wind up with decimals of 54 plus or minus 46.86 all over 8, which gives you 2 separate values. Gives you one value at 12.61 and another one at 0.89. Those are 2 separate values for x, for the width, for the possible width of the border. Which one of those do I have to throw out? Think about it. What's the width of the wall? 12. I can't have a border bigger than the wall, can I? So I have to throw that one out. So my answer would have been, I think the question asked you to round to the nearest tenth, so it would be 0.9 meters. Now, if I did this in the calculator, yeah, Trap.
Wait, why can't it be 12.9?
The problem itself said that the wall is only 12 by 15. So I can't have a border bigger than the wall.
Put it wrapped around the
It's just that the width of the wall is 12. I can't have a border that's bigger than the width of the wall.
Why not? I don't get why not.
I'll show you. Stand up. Hold this. There's your wall. Here's your border. Border's too big to fit on the wall.
Oh, I thought that was the, oh, no.
Does that make sense now?
Yeah.
Border doesn't fit on the wall.
But isn't the border supposed to be on the wall?
Right. But the border's bigger than the wall. Then you'd have no mural. No.
Now you're
So if I used the calculator, I would have done the same thing. What was it? Y equals x squared.
So it's like inside of it. So what is it inside of the wall, not outside? Yeah.
Yeah, the border is already on the wall. It's the trim.
So, okay, this is the wall, but the border is.
Yeah. So let's see. We had changed my window because we knew it was at max. We'll put it at 15. So you'll see you get 2 different zeros just by moving the graph around real quick. I would hit a second calculate 0 from there and a second calculate 0 there, and it works out to be about the same values. Ah. One 8, 9. Okay. Yes, ma'am. Okay. That's how those work. Hopefully they weren't too scary. Oh, I don't have it open. I believe I put on here, on the OB, I was very disappointed. I started searching through the new book past couple of days, trying to see if I could find you guys more problems and stuff like that for this. The new book doesn't have anything like this. It's very disheartening.
just looking over?
Quiz stuff. What I'm asking you guys to look at for the quiz stuff is that in chapter 5 we've done everything except for 5.7. 5.7 it was the graphing and shading of inequalities of quadratics. It's really easy to do, but with the lack of time, I thought it was better served that we spent a little bit extra time on these couple of word problems as opposed to, I know you guys could graph something and shade it. That's not that big of a deal. I am not putting on the quiz or the test itself simplifying I values, multiplying I together, rationalizing I together, because there's a button on your calculator.
Wait, we're not doing the I stuff?
When you simplifying, like how to rationalize it with the I in the denominator, I'm not putting that on there because the calculator does it. There's no reason for you to do that.
I actually know how to do that.
So don't worry about 5.4, but you still have to know how to, you still have to know how to simplify a radical that has an I in it. But I'm not going to ask you just to go ahead and simplify.
So like,
I'm not going to make you do, here, I'll show you.
so like what we did on that one quiz where you didn't let us use a calculator? We're not
Correct.
doing that. Okay.
Yeah, so if you scroll through here, I think what was it, 5.4? Yeah. Yeah, like this stuff, 8 plus I over 1 minus 2I. I'm not going to make you do that. Your calculator does it. I'm not going to make you combine like terms. Your calculator does it. But sometimes you could have an imaginary answer in one of these things. If you solve the equations via factoring or quadratic formula, complete the square, you can still get an imaginary solution. I'm just not going to have you simplify imaginary stuff. Does that make sense? So we have, going through all this then, back to the beginning, graphing. Graphing these things, we had 3 forms. You had standard, intercept, and vertex form. We talked a little about them again recently, about all the different parts of what H's and K's do. And I think it helped out a lot doing that modeling part, where I asked you guys to write the equations of what they were, and you were able to come up with the axis of symmetries and all that kind of stuff off of that. So that was very helpful for recall of those. In 5.2, 5.3, it was just all factoring. It was factor, take a square root, things like that. It was also very similar to what with those 4 questions I gave you guys to double check how you were working on those. 5.4 is those what we're not going to worry about. I'm not going to make you do that by hand. Your calculator does it. I think that's a pretty fair trade-off on it. 5.5, complete the square. Remember, completing the square isn't always the most efficient method. What is the best time to complete the square? Even B and no way to factor it. What has to be your value of A in order to complete the square? 1. It has to be 1. Okay. That's the only time you have to worry about that. Oh, by the way, what's your first rule of factoring?
Take it to UCF.
Thank you. After that, quadratic formula, discriminant. We know how to work with quadratic formula. The discriminant. Remember, there were 3 parts to the discriminant. The discriminant was either positive, negative, or zero. When it's positive, what kind of solutions do you have? 2.
Real solution.
If it's 0, what do you have?
1 real solution.
And if it's negative,
2 imaginary solution.
pretty straightforward. And then lastly was writing out the equations. If you had to write out the equations, remember, you have to remember which form it is. Is it intercept? Is it vertex? And is it the standard form? If it's standard form, that's the nice one. You're using your calculator with the matrices. The other 2, you have to do a little bit of substitution and go from there. I threw on here if you guys click on this, it says to look at the different sections. I am going to suggest, and obviously we have the word problem stuff. I think we pretty much did every word problem that I had even in this old book. That's why I found these other ones there. They're not going to be of any more craziness, complexity as to what we've looked at. They're going to be extraordinarily straightforward. It's a matter of making the decision and how to set it up. That's really all the hardest part of it is. What do I do? Do I use the calculator? It's understanding what do the values mean. Is it time in seconds? Is it a height value? Is it am I trying to find just the midpoint to get my cost, a sales style problem? I think I said, look at, was it 5.1, 5.2, 5.3, 5, 6, and 8. And that'll get you through all of it. It really shouldn't be scary. Okay? I know you guys are all freaking out because it's such a view. But don't. It's not worth it. Your brains will hurt. Yeah. That's all. Okay. Go through those. I'm trying to think if there's any other. On the next page, you did have a word problem. Yeah, it had there's a couple of word problems on the next page we didn't really look at. I wouldn't worry about 37. That's a little bit. We didn't do anything like that. If there's any problems that have an initial velocity, I will give that stuff to you, so you have to worry about remembering the formulas for initial velocity. Yes, ma'am. I don't know off the top of my head. I don't know off the top of my head. I don't know. Yes, ma'am. I would do those. I would definitely spend my time studying on that. Yeah, I wouldn't. I'm not going to collect it. It's kind of you.
Oh, that's their new year. Or
It's
the
just
new
yeah. It's just
And that has all that stuff in it?
Yeah. And what's nice, it's already on the website. What's nice is that these have really decent problems. They really do.
Are the answers up there, or can we like comment in the morning?
What page
Yeah,
is
swing
it?
by in the morning if you want to click the answers. I'll have it.
Wait, what page is
It's on the web, but just click on it. It says chapter 5 review. It's on that page. Yeah, it's right here. It's that old book track for some reason. It's the last one in the chapter 5 track. It's right there. Okay. I don't do that. I'm trying to think, do I have them? I could probably post the answers. Hey, you guys want me to post the answers for those? You guys want me to do that? You guys want me to post the answers on that?
Yeah.
I'll do that. I'll scan it next hour and I'll throw it in here. Yeah, they're in there. You just have to know the bottom. I see them from here. I'm looking right at them.
Yeah, there's only one.
Oh, flip to there's folders in here. Flip to the end of the page. Yeah, the only thing I will say is that unfortunately tomorrow morning we have a staff meeting. So I won't be here first thing. I'll be up here at like 7:30 as opposed to 7:15. So good times.
No, I'm just on this page.
Exciting. I love staff meetings. They're my favorite. Staff meetings.
I know I'm in the old one.
Yeah, Seb will be doing it today. I have to go. My father-in-law usually picks up Connor on Wednesdays, but he's not going to be around.